Hi, I'm Ryan Pineda, Application Engineer. Welcome to another episode of STL Edu Talk. Today, we'll talk about aerial optical fiber cables and their installation methods. What are aerial optical fiber cables? These are cables that are suspended in the air and connected from pole to pole or support structures. Aerial deployment of networks is faster and more cost-effective, especially for connections across rivers, rocky or uneven terrains. To eliminate the digital divide, aerial cables will be deployed massively in the suburban or rural areas to provide affordable broadband to all. Remember, type of cable deployment is dependent on terrain, climate, access to right-of-way like distribution or transmission lines, grounding and bonding, power utility communications and signaling networks, age and type of existing cable infrastructure serving the intended area. Let's look at the installation methods now. The most common method is where the cable is supported between poles by being lashed to a wire rope messenger strand with a small gauge wire. With lashed cable, the messenger strand component must be properly tensioned to resist the expected loading conditions. This is to keep the cable in minimal stress while maintaining sag in the messenger and cable and keeping them within safe specification limits. To simplify the placement of fiber optic cables on aerial plants, self-supporting cables were designed. First one of which is the figure 8 cable. A figure 8 cable gets its name from its shape. It incorporates both a steel messenger and the core of a standard or unitube optical fiber cable into a single jacket of figure 8 cross-section. This allows speedy one-step installation and results in a more durable aerial plant. But this results in increased cable diameter and weight, requires special tools and skilled manpower for installation, and most importantly, owing to metallic material presence, is highly susceptible to electricity and can be used near transmission lines. ADSS, all dielectric self-supporting cables, overcome these limitations. They are our second type of self-supporting cable. These cables don't suffer power coupling effects and bonding and grounding issues since they are fully dielectric. They are designed with their non-metallic strength member and support member. ADSS cables are developed using aramid yarn that has high strength, strong fabric integrity. They can be placed on either existing aerial support structure or new structure for unsupported spans of up to 1,000 meters in length. For short and medium span lengths, glass roving yarn or fiber reinforced plastic can be used instead of aramid yarn for cable strength. Since these cables use non-metallic materials, they can be mounted on its supporting structure at a level below any power utility plant, hence making this installation simpler, faster, and cost-effective. With different hardware options, ADSS cables can efficiently transfer the load to its supporting structure. Dead end supports provides a transfer of tensile load from the end of the cable to the ADSS support structure. Support and suspension provides vertical support to the cable. Vibration dampers used at the end of the ADSS cable to reduce the dynamic effect of wind and vibrations on the cable. Now, there are two main methods for placing aerial plant: stationary reel method and moving reel method. The stationary reel method. In this method, the cable reel is positioned at the starting end of the cable placement and positioned at least 50 to 60 feet from the first support. A sheave is positioned on each support structure. The cable end is attached to a winch line of similar unit weight to the cable with a double rotating swivel threaded through the support sheave on each support structure. Once pulled into position, the cable is transferred from the sheaves to the permanent cable support as it is tensioned to the specified levels. It can be used anywhere since it does not need an unobstructed right-of-way or vehicular access to the pole line. The moving reel method. In this method, the cable is paid off the top of the cable reel, carried by a moving vehicle as it drives along the pole line. As the vehicle passes each pole line, the cable is raised into place by a technician in a lift bucket, placed into a J-hook or block fitting bolted to support structure for temporary support. This procedure continues up to the dead end pole. Here, the cable is tensioned and terminated into dead end fittings. For ADSS cables, the moving reel method is more productive and less labor intensive. However, the biggest challenge for any aerial cable plant is cable breakage. Pole infrastructure is susceptible to collapse due to high winds, extreme temperatures, falling tree branches, and vehicle accidents. These can cause large-scale damage and can be fatal too. To address this, STL has designed an innovative braking load-optimized, work-safe aerial cable with the required tensile strength and an optimum predictable point of breakage. In the event of a hazard, the cable will break first without damaging the supporting pole structure, surrounding property, and working personnel. Interested to know more about STL's range of innovative optical fiber cable and detailed instructions of ADSS cable placing procedures? Visit our website at stl.tech or contact our sales representative now.